Okay, the next that we have here is limit of e raised to x plus e raised to minus x minus 2 into x square minus 3x plus 2 divided by x minus 1 is equal to x. As x approaches 0 is equal to which among these values? Now, as I told, in all these examples which are clubbed together, they were already taken to be indeterminate. So deliberately we have an example over here. So let us see whether we do the exercise again. Substitute the value of x as 0 in the denominator. Is it meaningful or no? Let's see. It's 0 minus 1 is minus 1, which is determinate. So this one we need have to factorize. You can do by factorizing, because x square minus 3x plus 2 can be written as x minus 2 into x minus 1. But otherwise we need not do. Much the same way over here. In this case, limit of this particular function as x raised to 0 is the value of the function when x is equal to 0, because it is a determinate function. So you just need to substitute. This will give you e raised to 0 plus e raised to 0 again, minus 0, 0, minus 2 into 0 square minus 3 into 0 plus 2 divided by 0 minus 1. Now this will become 1 plus 1 minus 2 into 2 divided by minus 1. This will turn out to be 0 into 2 upon minus 1, which is 0 itself. So the value of this particular limit is 0. That is this. So in such cases, we just need to check the denominator whether it is meaningful or no. If it is, you can directly substitute the value of the variable. If not, factorize it. Okay, so we do get it as 0. Okay, now here we have again another expression. We have 4 minus x square upon 3 minus root x square plus 5. Now again, as I told, whenever the denominator or numerator has an irrational number, we can multiply by the conjugate. This will be written as into 3 plus root x square plus 5. This denominator also will be multiplied by 3 plus root x square plus 5. So this will give you 4 minus x square into 3 plus root. So we get 9, 3 square minus x square plus 5, using the formula that a minus b into a plus b is a square minus b square. This will turn out to be, this is 4 minus x square into 3 plus root x square plus 5 upon 9 minus x square plus 5. Again, this will turn out to be 4 minus, this gets cancelled, and you get this 3 plus root of x square plus 5. Now it has become a determinate function, so limit of function as x approaches 2 is the same as f of 2 now, which will turn out to be 3 plus 2 square plus 5, that is 3 plus root 9, which will be 3 plus 3, which is 6. So correct answer is 6 over here. We have yet again does the same concept of multiplying numerator and denominator by the conjugate of the irrational part, right? We're getting it as 6 for sure. Okay. Now, again, we have this kind of we came across this kind of a situation earlier too. So we have f of x is equal to 1 by 3 plus 1 by 3 square. The more we have sums of slightly peculiar ones, again, after a regular interval, we will be able to get our fundamentals better, because we'll try to recollect what we have. So again, this is a summation here. So this, if you see, it's a GP, geometric progression, where A is 1 by 3, R is nothing but T2 by T1 or T3 by T2, R is also 1 by 3, and R is less than 1. So in that case, this Sn is nothing but A into 1 minus R raised to n upon 1 minus R. So A is going to be 1 by 3 into 1 minus 1 by 3 the whole raised to n upon 1 minus 1 by 3. Now you see that as n approaches infinity, 1 by 3 raised to n will approach 0. As we did earlier, 1 by 3 is just 1 by 3. 1 by 3 square is 1 by 9, which is much smaller than 1 by 3. Then as you increase 1 by 3 raised to n, the denominator becomes larger and larger, numerator remains the same, hence the value of 1 by 3 raised to n approaches 0. So ultimately you have to find out the limit of this function. The limit is determinate, is the same as f of infinity, which is nothing but 1 by 3 into 1 minus, this turns out to be 0, upon 1 minus 1 by 3. 3 ones are 3 minus 1, 2 by 3. So it's 1 by 3 into 3 by 2 into 1. So this turns out to be half. So the value of this particular limit is nothing but half. Let's check. Yes, we do get it as half. Okay, so what do we have? 9x squared minus 1 divided by 3x plus 1 as x approaches minus 1 by 3. So here if you substitute x as minus 1 by 3, you get minus 1 plus 1, which is 0, which is indeterminate, so we need to factorize it. Now since we need to factorize it, this numerator is 9x squared minus 1, hence it can be written as 3x minus 1 into 3x plus 1 divided by 3x plus 1. So this gets eliminated. You get 3x minus 1 is f of x. Now this is determinate value, so limit of f of x as x approaches minus 1 by 3 will be f of minus 1 by 3 itself, because the expression has become determinate. So substitute 3 into minus 1 by 3 minus 1. This gets cancelled. Minus 1 is minus 2. So it is minus 2. So do we have it that way here? With a simple example. Okay, again we have root of 4 plus 3x minus root 4 minus 3x, the familiar process of multiplying by the conjugate. So f of x is root 4 plus 3x minus root 4 minus 3x upon x. You need to find. So you need to multiply by root 4 plus 3x plus root 4 plus 3x. The numerator has the denominator also has to be multiplied. I'm sorry, this is 4 minus 3x plus root 4 minus 3x. This will be a minus b into a plus b, so it will become root of 4 plus 3x the whole square minus root of 4 minus 3x the whole square upon x into root 4 plus 3x plus root 4 minus 3x. Now this will become 4 plus 3x minus of 4 minus 3x, which is minus 4 plus 3x. 4 and minus 4 get cancelled upon x into whatever it is. This will now become 6x upon x into root 4 plus 3x plus root 4 minus 3x. Again, this is indeterminate because x is here, we need to mention limit as x approaches 0. Right. So this of course gets cancelled. So now we need to find out f of 0, because once the expression has become determinate, so you get 6 upon root 4 plus 3 into 0 plus root 4 minus 3 into 0. This will become 6 upon root 4, that is 2, plus 2, root 4, that is 6 by 4, which is the same as 3 upon 2. So again, in this case too, we have multiplied by the conjugate. So ultimately you get a rational number and then you substitute the values. So we're getting the value of this limit as 3 by 2. So our correct option is 3 by 2. Limit as x approaches 0. Value of this particular function is 3 by 2. Alright, yes, we do have it as 3 by 2. Okay, this one again is similar to that. So we have here the function as x squared minus 1 upon root 3x plus 1 minus root 5x minus 1 as x approaches 1. So if you substitute x approaches 1, you get 3 plus 1, 4, that is root 4, 2. 5 into 1, 5 minus 4, 5 minus 1, 4. So it is 2 minus 2, 0. So the expression becomes indeterminate if you directly find out f of 1. So we need to factorize or simplify it. So this will give you x square minus 1, which is the same as possibly x minus 1 into x plus 1. And you multiply by the conjugate, that is 3x plus 1 plus root 5x minus 1. And this denominator is root 3x plus 1 plus root 5x plus 1. This will give you x minus 1 into what? Into x plus 1 into this whole thing in bracket divided by root 3x plus 1 the whole square minus root 5x minus 1 the whole square, which ultimately turns out to be x minus 1 into x plus 1 into whatever you get over here upon 3x plus 1 minus 5x plus 1, which will be x minus 1 into x plus 1 into the terms inside upon, this will give you 3x minus 5x minus 2x plus 2, which can be written as minus of 2 into x minus 1. Because it turns out to be minus 2x plus 2, here x minus 1 gets cancelled, so you get a determinate quantity now. So ultimately, limit of f of x as x approaches 1 will be nothing but f of 1, which will turn out to be 1 plus 1 into this particular expression which we had in the numerator, which will turn out to be root 3x plus 1 plus root 5x plus 1, right? So this will turn out to be root of 3 into 1 plus 1 plus root 5 into 1 plus 1. 1 minus 1, I'm sorry. So upon minus 2, this will turn out to be 2 into root 4 plus 5 into 1, 5 minus 1 into root 4 upon minus 2. This gets eliminated. When they will do root 4 plus root 4 is 2 plus 2, 4 divided by minus 1. So it is minus 4. So among these options, we get the answer as minus 4. Yes, we do get it that way. Okay. Then limit again of root of x plus h minus root x upon h as h approaches 0. So this again is an indeterminate quantity, so we need to make it rationalize the denominator. So we have numerator in this case. So f of x turns out to be root x plus h minus root x upon h. So you need to multiply by the conjugate of this, which is root x plus h plus root x. But since you have multiplied the numerator, you need to multiply the denominator too. It will be root x plus h plus root x. Now this numerator will turn out to be root x plus h the whole square minus root x the whole square upon h into root x plus h plus root x. This turns out to be x plus h minus x upon h into root x plus h plus root x. Here these two get cancelled, even this h and this, so ultimately you end up getting f of x upon 1 upon root of x plus h plus root h. And you have been asked to find out you have x plus h. So okay, as h approaches 0, so you end up getting, this is x of course, sorry, x. So now limit of f of x as h approaches 0 is nothing but f of h itself, f of 0, that is taking f of h as 0. So it will turn out to be 1 upon root of x plus 0 plus root x. See, this is now a function of h, since we are taking h, the variable is h, which is approaching 0, which means the function is h. So we don't write it as f of x, but we write it as, I'm sorry, here also there is a small mistake, it is f of h. So h is a variable, so wherever there is h you get, so you end up getting root x plus root x, which will turn out to be 1 upon 2 root x. So we have 1 upon 2 root x. This is the right answer. Yes, we do get it that way. Okay, here we have a question. F of x is x cubed plus 3x squared minus 9x minus 2 divided by x cubed minus x minus 6, and limit f of x exists. Then what is the limit of f of x as x tends to 2? So this should be limit of f of x as x tends to 2. Now we need to factorize all these. So here if you see, we end up getting x cubed plus 3x squared minus 9x minus 2. Sum of the coefficients 1 plus 3 is not 0. Sum of odd coefficients is also not equal. So we cannot, neither is x plus 1 a factor nor x minus 1 a factor. So what do we do in such cases? We have to find out what could be the factor. You need to take a hint. See, x is approaching 2. So we need to substitute, put x as 2 in the numerator. When you put x as 2, you get 2 cube plus 3 into 2 square minus 9 into 2 minus 2, which will turn out to be 8 plus 12 minus 18 minus 2, which turns out to be 0. Which means that the value of the numerator is 0 when x is equal to 2. That means x minus 2 is a factor. It is quite clear that x minus 2 is a factor for the numerator. So if you perform synthetic division, we put, since x minus 2 is a factor, we put 2 here. So you get 1, 3, minus 9 and minus 2. So you get 1, 2, 3 plus 2, 5. 5 2s are 10, 1. 2 into 1, 2 turns out to be 0. So the numerator turns out to be x minus 2 into x square plus 5x plus 1. The denominator, what can we do? Similarly, we could put in x is 2 and go ahead and do it. Or there is another way of doing it. We could possibly split the middle term x cubed minus 3x plus 2x minus 6, because minus 3 plus 2 is minus 1. So we can take it x cubed minus 3x plus 2x. So x cubed minus 3x minus 2x plus 6, can we factorize this? No, it doesn't seem to be happening. So we cannot factorize possibly, basically, because if we take out x common, you get x squared minus 3, and this is 2 into x minus 3, which may not happen. So we may have to do by synthetic division. Now take a hint. You have an x minus 2 as a factor. In all probabilities, denominator also should have x minus 2 as a factor. So let's substitute the values. 2 cube is 8, minus 2, 6, 6 minus 6, 0. So even for this, x minus 2 is a factor. So we can do by synthetic division, this one 2. So you get x cubed coefficient 1. There is no x squared term, hence 0. X terms coefficient is minus 1 and minus 6. And again we introduce 2 here, so we get 1, 2 into 1, 2, 0 plus 2, 2, 2 2s are 4, 6. So the denominator turns out to be x minus 2 into x square plus 2x plus 3. So now again this gets cancelled. So f of x turns out to be this. Now for the value of x is equal to 2, the denominator, the expression is determinate. So find out now the limit of f of x as x approaches 2 is nothing but f of 2 itself, which is 2 square plus 5 into 2 plus 1 upon 2 square plus 2 into 2 plus 3, which will turn out to be 4 plus 10, 4 plus 10, 14 plus 1, 15, and the denominator is 4 plus 4, 8 plus 3, 11. So the value of this particular limit, which is the same as value of the function when f of fx is equal to 2, is 15 upon 11, which is the same as this. So in some cases you may have to perform synthetic division and find the factors. Yes, we do get it as 15 upon 11. So in the sections that we did till now, we came across simple expressions wherein we need to factorize. Sometimes we had to multiply the numerator and denominator by the conjugate, and in many cases for the given value of x, if the expression remained determinate, we could directly substitute that particular value of x and get the value, and in some cases substituting that particular value of the variable would render the expression meaningless. In such cases the limit has to be found out by first factorizing and cancelling away the factors which is making it indeterminate, and then find the value of the function for the given value of the variable. So these are the kind of examples that we did now. Now from this we will move over to a few more new concepts and limits.